And welcome back. Now today I'm going to show you how we can get code to this device from the Arduino IDE and update it over the air, not the USB cable, like this. Easy. Keep watching. Indeed. Now it really is easy, right? And I hope I've made it even easier and more useful. But let's start at the beginning. Let's assume that this device that's flashing the LED and whatnot on my workbench is in fact controlling my entire workshop here, probably sending a rocket to the moon, counting bees in the beehive, whatever. Yeah, it's doing some work, and where that device is now installed is pretty inaccessible. And you think, if only I could get to it to change the code. Well, now you can. By using over-the-air updates, you can just say to your Wi-Fi, basically, I want to go to this page, which is on that device, and you go, here's my new code. Tra-la! Well, you saw it in the intro, didn't you? It really is that easy. Right, what are the steps we need to do? I want to do a shout out for JLC PCB. No, stop, don't go away. Look what they're doing. $2 for aluminium circuit boards. This is absolutely incredible. If you've ever wanted to try an aluminium PCB, now's the time to do it. Now remember, aluminium PCB is a single-sided normally with the aluminium on the bottom. Then you have a dielectric layer that transfers the heat up to the top copper layer. Now aluminium is very, very strong, and it will suck the heat away out of your components without the need for extra heat sinks, for example. Go and have a look at their website and check them out. And there's more. JLC PCB now allow you to create your own parts library, because there's nothing more disappointing than creating a PCB and then finding you can't get the parts or there's a big long delay. Now you can create your own custom parts library to ensure you get the components you need, and of course the associated footprints, so you know they're going to fit on the PCB itself. To get to this page that describes everything you ever need to know about creating your parts library, simply go to their homepage and then click on the link at the top. Very, very simple and a really, really useful feature. Go and check out JLC PCB now. Okay, here are the steps we need to do. First step, we need 3 libraries. Now one you can get directly via the Arduino IDE, but the other 2 you have to go to GitHub, download them and then put them into the Arduino IDE. Let's do that very quickly, because I'm assuming even if you are a beginner, you know how to install libraries into your environment. So let's just whiz through that in a couple of minutes. Right, there are 3 libraries we need. The 4th one is already included into your ESP32 or ESP8266 environment, so we can not do anything with the Wi-Fi library that's there. But the 3 you need, there they are on screen now. Follow the links in my description below or on the GitHub. Go to GitHub and do the following. So this is one of the libraries we need. It's Async TCP. The me no dev moniker up there is in fact a chap called Hristo Gochkov, and he's I think he's actually employed by Espressif. If not, I'd like to know why he's producing everything there is to know about ESP32s and the like. But anyway, he produces all these libraries, so I'm guessing it's Espressif based. But anyway, this is the first one. Now what you do for all 3, the same process. Go to the GitHub link that's down there, right? There's 3 libraries, this is one of them. Go to the code button that you see there, click that, and where it says download zip, do just that. Click that and it will appear in your downloads file. Right, let's assume you've downloaded all 3 libraries now. They're sitting in your downloads folder or some other folder where you know where they are. That's fine. Go back to your Arduino sketch and say, go to the top of the menu bar there and say sketch, and you say include library, and you see there's a drop down list there. Well, you can see straight away that I've actually got some libraries already included. What you say is add zip library. Click that and it will go, where is this library? And it always defaults to this funny folder. I don't know what this is. Anyway, if we go to downloads now, so here we are, here's my downloads folder, and you can see that the ones we're interested in are here, like Async TCP and ESP Async Web Server. Yes, they've all got this dash master bit on the end, right? That's a GitHub thing, don't worry about it. You select those and Arduino will import those libraries and they'll be available for use exactly as they are for me. Great, that's it. You've got your libraries in place. Let's move on. Right, just a recap of what this board is doing. It's flashing an LED, as you can see, but really controlling NASA or something, right? And it's also outputting stuff, yeah, ironically, to the serial port via the USB, just so that we can see what's happening as we upload over the air, and you can see what's happening. Normally, of course, if this was now buried deep in my beehive, you wouldn't have that cable attached. So let's go back to the code and see what marvelous code I've written to make that LED flash. Right, very simply then, we've defined the LED pin as pin 15. It's just one I've chosen out that array of pins we have on an ESP32. In the setup, we're saying the pin mode is output. Obviously, it's going to go right to it. And then we have the magic line that says OTA init. Yeah, this is the initialization of the over-the-air stuff. Yeah, but we'll come on to that. Let's see this working, yeah? So the loop basically says... well, there's a couple of counters in here, and we're saying we're outputting something to the serial monitor via the USB cable just to have a little count so you can see it awake and any other messages that might come out of there. And then this line here flashes the LED every so often, right? So, okay, so we'll pretend this is doing a lot more than that. How are we going to upload this then to a bare device that knows nothing about over the air? Okay, we're in a catch-22, aren't we? You've got to make sure that the very first upload is the traditional way via the cable. Otherwise, there's no code on the ESP32 to do anything. So the first time round, just upload it via the USB method as normal and get the thing running. Let's see it actually in action running so we know it's there. Now, I've reset the device because there's something on it you need to look at, and it's important, right? In the code, I output the IP address that device is running on, and you can see that here in the actual serial monitor. I'm using CoolTerm, but you could use the standard one built into the Arduino IDE. The important bit, though, it says is, look here, I'm running on 192.168.1.83. and that address has been assigned by the DHCP server of my router. And if you know about networking, you can either make it fixed or not, it's up to you, but it's important that you output the IP address so you know what to type in to find it, especially if you've got more than one of these devices lying around. Yeah. Okay, so now we know the IP address that device is running on, just like any other web server in the whole world. They all need an IP address, but your one is a local IP address. It only applies to you. Nobody else can get hold of it. Great. Now we know that it's running, and you see it's outputting counters every 3 seconds, right? How are we now going to update that then? Well, we know the address. You've just seen it. Yeah, 192.168.1.83. Well, let's go to a web page now, a standard Chrome browser, whatever you use, and let's see what happens. So here we have a fresh web page. So I'm just going to type in the IP address that we just saw on that serial monitor. So 192.168.1.83, and there it is. Now this landing page, if you like, this home page, I've put together as sort of added value on top of the stuff that other people who have come before me, okay, because I found it much more useful doing it this way. And the reason I've done this is because the other way was a little bit generic. You never knew which device you'd actually connected to, even if you'd known the IP address or thought you'd known the IP address, right? So here it says, great, you've reached your beehive counter. Ah, yes, it's the right one. That's the one I want to update. And it tells me I'm on that right address. Look, 192.168.1.83, as I suspected, okay? Right, there's a project description here that you can write as part of your code. A simple little bit of text just to remind you. Perhaps there's some very funny things about your particular project. You think, I must not forget this next time. Well, you will forget unless you write it as part of the sketch, because then you can read it here in future. Okay, and the title of this page, the actual tab title, is the title you've typed in that project as well. Basically here it's called Beehive Counter. It's very important, of course, that you don't upload code from your mega marvelous project to the wrong device. Okay, so what this is saying is, right, how do we get this code up here using OTA? Right, it tells you here, but let's go and do it step by step, shall we? Right, so you've written your code and you've compiled it in the normal fashion using the verify button at the top there, that one, yeah, this is verify, and it's all working. You think, okay, time to upload now over the air to my device. The way you do that, you go to Sketch and you say export compiled binary. I don't know if they're going to change the functionality in this, but all it does is basically does another recompilation. Yeah, I know, it takes forever. And puts it in the same sketch folder as your sketch. So if we say export compiled binary, you'll see, well, off it goes. And I might speed this up a little bit actually, because it takes a while. Okay, it's just coming into the linking phase now, which means basically the compilation error didn't find any errors. Now it'll link it and it will put this output into a special folder, and you'll go, where's my sketch? I can't remember where my sketch was. Yeah, that's easy to find. You just go to sketch again at the top there on the menu, and you say show sketch folder. So this is the build folder now, where you've actually created your sketch. There's your sketch, look, ESP Eno file, yeah, and there's a new folder called build in it. So if we double click the build, there's another subfolder. These names are made up, I'm sure. And then we have these bits in here. Now let's keep away from the partitions bit. We'll cover that in a future video perhaps. Eno.elf folder, we don't want the elf. It's the bin folder we're after. Bin, right? That's the one we need. So when we come to upload our code over the air, that's the one we need from that sketch folder. And the good thing is the over the air system remembers where you last got it from. So let's go back to the browser and see if we can pick up this code. Right, here we are then at the landing page, the home page of your device, and it gives the same instructions here, a little bit more tersely as to what I've just shown you, and I've even given you a little link there so we can either type that in the address bar up here, yeah, or just click it. I guess what I'm going to do. Right, now this is now going to say where is that file that you are going to use to upload. Once the page is loaded, just click the button to say choose file, and you'll go back to that folder we just found out about and choose the file from there. So choose file. Where is it? It says. Now it's going to download because I've been mucking about. But if we go to my Arduino sketches folder, we'll find it in there. And there's the file. And we just double click that and the update starts immediately. As you can see, it starts immediately and starts trundling on. And there we are. Normally it's about the same speed as if you're to upload with the USB cable. Okay, right, that's done then. That now resets the device, and which then of course runs on the new code. Right, okay, let's actually change the code now and prove that it's going to be uploaded over the air. All right, now in between time of the last bit of video and now, on taking the dog out for a walk and all that, I've decided to change the board because it just makes it a little bit easier for me to use. And that last board was a 16 megabyte RAM one, and it was playing up a little bit. I've got to be honest, it's the first time I've used it. So I'm back to a tried and trusted ESP32 now. So we're on pin 13 for our flashy LED. And let's scroll down a bit to the code. So here, where we're saying, you know, make the LED light for 100 milliseconds out of the full second, let's change that to 500. So now it should be equal mark space ratio. On and off should be the same. Just go back to the main window to see what it looks like. So there it is at the moment. Now you can see I've got these two wires here now, because I'm going to power the board, not from the USB, but from the power supply. So if I disconnect, right, so it's still running, but no USB, okay? So if we go back to the code window, right, now we've changed this code here. Okay, got it on pin 13, that's fine. Now what we're going to do is compile and export that binary into a new folder. Okay, let me just do that quickly and then we'll go back to the web page to do it. Right, so that's compiling, and eventually it will throw it over the wall to that folder, and we can see when that's ready just by going to the browser. So here's our browser, choose file. Right, so here's our pop-up window that says where's the file then, and what's the time? 16:55. And it is 16:55. Yes, I know, I work long days, don't I? Right, let's double click that, and right, so that's uploading, and whilst that's uploading we're going to whiz back to the desktop, and you should see the flash rate change. So there it's flashing as it always used to, just a quick flash, yeah, out of the lot. Oh, here I am. I'm back. Oh, it stopped flashing now because it's rebooting. It's trying to get hold of the Wi-Fi connection again. And do we have success? There it goes. Right. There we are. Now you can tell that's a much slower flash rate than what it was before. So the over-the-air upload has worked fine. Now, of course, now let's just take it a step backwards here. As you can imagine, if you're uploading new code to your device that's stuck in the middle of a beehive and you get it wrong so that the device does not run that code properly anymore, it hangs or crashes constantly, you know, rebooting all the time, you're stuck. So you do have to be really, really careful about the quality of your code that you're delivering out into the wild, as it were. So if you've got an inaccessible ESP32 device that you're uploading via over the air, you really should have a test rig with exactly the same hardware on it that you're doing all your updates to, also over the air, to make sure that still works, but you can use a USB cable too. Before you go, this is it, finally tested, now I'll release that to live. And that's exactly how I do it to my ESP32 web radio. I don't want that suddenly not working if I've got some little tweak done to it. So you have to be very careful. Okay, so well and good, it all works. I mean, you can take it from me, it works for millions of other people as well. So what's the code behind it? How does it work? Now, so far we've only had a look at this little bit of code, and I said, look, it's this one line here that does all the work. And that is true, that is the one line. Of course, there's a tiny bit more to it because we've added value here. Well, I hope it's added value. If we scroll to the top of this code, you'll see exactly what's needed. Right, there's two things first of all you have to type in. First of all is the SSID of your Wi-Fi and your password as well. Now there's two other things that you need to put in. One is the project title, and keep this really short, yeah, not some long verbose thing, because that's what's going to appear in both the Chrome or whatever browser you use tab and also on the page, right? So I've called mine Beehive Counter, that's great. And then you can say the project description. This is really an aide-memoire for you, just to make sure you don't forget things like, you know, turn off this or disconnect that before you upload, something of that ilk. Yeah, so I've just typed something in here. As you can see, this is a long string, so I've split it, and you can split a string just by putting a backslash at the end of the line and then continuing it as though it was all just one big long string. Just makes it a lot easier. Okay. Now the project description can be plain text, or it can be HTML if you know HTML. Right. Good time to try it out, really, isn't it? And then you include this library here, the identification.h. which is what I've put together, standing on the shoulders of giants, as it were, and I'll show you that in just a sec. So that's all you have to do at the beginning of your project to make it, well, OTA enabled and indeed web server enabled. Yeah, okay. Right, let's have a look at this code, but I would suggest that unless you know what you're doing, don't fiddle about too much with that file because you'll break things. Right, now this is the identification.h, the header file, but it contains code, okay? Here we've said, look, there are two external strings, in other words, declared somewhere else in another file, but take it from me that they are there. That's what we're telling the compiler, called project title and project desk. Hence, if you look at the main sketch here, this is where you've defined your project title, nice and short, and then some kind of description. There's your SSID and password, which are also defined externally. Here we start a async web server, just so that we can access it. And in the OTA init, which is that one line that we call, we do all the Wi-Fi stuff. Yeah, we connect to the SSID, set the power and all that, print a few things like the IP address and all that down here. And then say a couple of bits here just to say when I get a web request from a browser slash just the name of the IP address, it sends out all this stuff here. Now if you don't know HTML at all, this will be like Greek to you, right? Absolutely like Greek, so do not touch it. If you know HTML and ideally a bit of CSS as well, there's no JavaScript though, you'll be able to tweak this and make it your own. But what I've found is I'm going to put this into my libraries folder under a different, the top level folder called identification. So, and then this will be in it, and I'll be able to copy the same file in to all my ESP32 projects then, rather than having a slightly different one or multiple copies of the same one. But if you don't know what this is, leave it alone basically. Right, and the last two lines of this file just say, right, start the Elegant OTA server and the standard server, and that's it. That's all that file does. And what that actually gives you is the bit we've already seen in the browser. That. Okay. And if you notice in this browser, this is the bit that you wrote. So project description, all this is what you wrote in the sketch at the top, and the tab, which is called Beehive Counter. You can't see it, it's gone off the screen here because the way it captures the window, but basically Beehive Counter is at the top tab. So if you've got, I don't know, let's say 2 or 3 ESP32 devices that you're updating over the air, you'll see which one it is at a glance. And there's some simple little instructions that you saw that was being compiled out of that little bit of HTML. It's pretty standard stuff, as I say. Yeah, I mean, to be quite honest, that file reminds me very much of 1999. That's when I started doing all this HTML stuff. And it grew from there. Right, that's it then. So basically, forget this identification.h, just include that into your sketch like that, having set these other things first. If you don't set these first, this will not compile correctly, because it says, after all, I've declared some stuff externally, and it goes, no, you haven't. Kaboom. Right, so make sure you put these in. Okay, and that's it. So it's those 4 declarations really, the include file, and then that one line OTA in it, and it works, and it adds value. So I'm going to add this to my ESP32 web radio. It will be on my smart workshop heater controller, which is coming along nicely, and anywhere else I can think of really. I wish I'd used the ESP32s now, my bin lid monitors. But maybe I'll use it on the receiver side in here, because I think it would just lend itself to it. Once you've got a thing all screwed up in a box, you don't really want to have to go to it, take it off the wall, unscrew it, find a USB cable, somehow get it into the device just to upload a bit of code. What it means is you don't bother anymore. Yeah, and well, if you've got an enhancement to make or sort of fix or just want to tweak something, it's nice to be able to do it, isn't it? But beware what I said. Test it out first. Cool. I think we're just about there actually. Right, we'll leave a nice shot of a flashing LED. See, it does come in useful sometimes. And say, great. If you've got any questions, by all means put them down into the comments. All you people who have done this to the nth degree before know I'm not using the Arduino standard OTA because I found it very cumbersome in the past, and I didn't like it, and it sort of put me off a bit really. But when I found this elegant one, then I thought, hey, this is good. I like it. Right, well, if you like the video, give it a good thumbs up. Yeah, it's getting better. It's getting better slowly. Yeah, going back on Thursday and have it redressed. And what else? Oh yes, if you want to subscribe to the channel, do so, and then tick the notification bell so you get notified of new videos. Otherwise, you'll never hear from me again, subscription or not. And I guess we're done. See you next time. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.